Hello, everyone. Welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me today I have
Mathew Smith, the director for the Centre for Welding Technologies and Metallurgy Research at BCIT.
And we're here to talk about robots. But before we do that, actually cobots, not just robots, so which we'll explain in a bit. But before we do that, maybe you could give us a little bit of your background and what the department does.
Sure. The department at BCIT is a relatively new department. It was started around 2 years ago through a grant that was given to us by C-SPAN. And they essentially were looking to establish a center in BC that could start to do applied research related to welding and applied welding technologies. My background is I've essentially worked in industry for the past 15 years as a consulting welding engineer. I've worked for hundreds of companies in British Columbia across pretty much any industry that you think, that welding could be involved in. Developing welding procedures, giving people advice on what welding equipment to use, how to approach the welding that they're gonna do. Have experience in the shipyards as well, developing welding procedures for C-SPAN. And so, yeah, I haven't really been involved in an academic or research role for quite a long time, but it's kind of coming into it really with an industry focus, and looking at what we can do from an applied research point of view to advance the welding industry in British Columbia.
Now, one of the things that is in the department is these things called cobots, which are
right.
Well, we'll explain that in a bit. But robots generally, am I wrong in thinking that they've kind of been part of the scene for quite a while now, at least in construction, like say auto building? There've always been welding robots there. Or correct me if I'm wrong here. Maybe I'm confusing.
I think robotics and automation welding is one of those key industries where you see robotics and automation applied.
Right.
Where they're typically applied is in businesses where you have what they call low mix, high volume components. So the auto industry is a really good example of that. You're setting up a fabrication line and you're going to weld. One robot's going to do one weld on thousands and thousands of cars. So you program it once and then it just does what you programmed it to do, over and over and over again with no variability. And so in those situations, the labor that's involved in programming the robot and getting it to do the weld that you want properly is more than offset by the repeatability.
Right.
And that's kind of like the traditional realm for robotics and automation. And in British Columbia, we traditionally haven't had a lot of that type of fabrication. There aren't a lot of companies that use robotic welding. There's companies that have maybe tried. They would buy kind of a traditional robot. They'd have one or two guys work for them. We don't really have proper training in the province for how to use these things. They train their guy, they'd program it. The guy would maybe leave and go work somewhere else, and then they'd end up with hundreds of thousands of dollars worth of equipment sitting in a corner. No one really knows how to program it, and it's that's kind of like the way that it's been in British Columbia for a long time, I think.
Now, a classroom setting is the exact opposite of what you described, and so that's where these cobots come in. So maybe you could explain what a cobot is in the first place.
Yeah, so we're just about like a traditional robot. And the way a traditional robot would work is that you create a program for it, whether that's through a teach pendant, they call it, like an interface that's linked into the robot, or offline programming, and you tell the robot, follow my program, and the robot will do that. And it will do that regardless of what's going on around it. So if someone happens to be standing next to it and you've told it swing to the right, it will swing to the right. And if the person happens to be standing there, it's just going to swing into them. If you said it close up and someone happens to have their arm, in between where the two arms of the robot and it closes, it'll just, it'll tear their arm off, right? So with those kind of traditional robots, you have to put them in some sort of fencing, either physical fencing, laser fencing, something of that nature, and you tell it what to do programmatically, and off it goes. a cobot is different in that it has sensors built into it, so that you can work around it without really needing to worry about it running into you or it doing things that would be potentially dangerous towards people working around it. So the cobot means collaborative robot, and what it essentially means is that with the sensors built into the robot, you can get it to run your program, but if it senses a problem, it runs into a person or any other kind of object, it's just going to stop, and so you can safely work around it, whereas you couldn't do that with traditional robot. What that opens up is the different ways of interacting with the robot, because now a person can physically, to do the programming, rather than having to rely on sort of remotely programming it, you can essentially just reach out and grab the robot and point it where you want it to go. And so that's one of the key things that's really opening up is it changes the way that you can interact with the robot. It makes it a lot easier to program, because essentially now all of that's kind of school setting of learning how to control the robot, learning how to program the robot is out of the window. You could essentially grab the robot, pull it to where you want to start a world, hit a button on your, it's essentially an iPad, or I think it's an Android tablet, but you basically tell it this is the world start. Grab the robot, take it to where you want the world to stop, and another button on the tablet, this is to stop. And that's all that's really involved in programming it. And so it makes the programming a lot simpler. It makes kind of safety issues of working in and around robotics a lot simpler. And so it starts to open up the idea of like being able to have these types of robots on a shop floor. And, that a welder or someone who doesn't have a background in computer programming or understanding how to program a robot can just use the robot or use the cobot to perform welds.
And like you said, you can grab it and move it around the shop floor. This isn't $100,000, and it's certainly not sitting in the corner. So it's smaller and it's cheaper. And so maybe you could go into what that opens up for you, besides what you just described.
Yeah, I think really what the idea of it is that you could start to use them for. So we talked about the limitations of a traditional robot being, but it's low mix, high volume parts. If you can get the programming overhead down to a point where it's very easy to program the robot or the cobot, then you can start to do things that are not so high mix. So you might have a part that you need to weld 20 of or something, but not thousands of. That's it's a relatively repetitive weld. It's a simple weld, something that like your average welder might not actually want to do because it's quite a boring thing to do. We're just running a fillet weld or something of that nature, where it's something that the first day of school they kind of learn how to do it. They have to do it because it's their job, but they maybe don't really want to do it. And they might have this cobot available to them, and they can quickly set it up to do that weld, and then they're off doing something that's maybe a bit more challenging or a little bit more interesting. And so then it opens up the idea of being able to work with the robot, collaborate with the robot. The welder is getting it to do certain tasks for them. They're still welding on other tasks. And, especially in kind of the world we're in right now, where we have labor shortages for welders. It's not forecast to get any better in the next, 10 to 15 years, that you could start to have on the shop floor these small collaborative robots. The learning overhead is relatively low on how to implement them, and they can start to do some of the sort of the simpler tasks, and that frees up, the welder to do some of the more skilled tasks that a welder would typically do.
And just in terms of learning, I think I read somewhere in a BCIT release that this doesn't preclude people learning all the manual labor, or not manual labor is not the right way to put it, skilled labor, obviously, but it's the manual dexterity of it is what I'm trying to say. It's they have to know how to use stuff with their hands, because that's key to the whole thing, regardless of whether you have a robot.
I think so. Yeah. Like I mean, I'm not a welder. I'm an engineer, and I can program it. I can get it to do pretty decent welds, but it takes some work, right? And then, but when we have students who are coming in and working with us who already have a background of welding, so they've already completed a C-ticket welding, or they've been working in the welding industry, their knowledge of welding makes it extremely easy for them to pick up and use this, because they understand, gun angles and wire feeds and all of the other different parameters that go into ensuring a good weld. So it's not that you can just get, this is, somebody who's never welded before,
Right.
and we'll get them to a point where they can just use this thing and then we can replace the skilled labor. Like, that won't work. But what does work really well is if you have someone who understands welding, is trained as a welder, and then they can come in and say, okay, I can get this robot or cobot to do this task for me. And they understand what the cobot can do and what it can't do, what's a simple weld for it to do, what, requires, more interaction. So it's not, I think it's like, the way to think of it is, it's like it enhances your ability to work, but it doesn't replace the need to understand welding or learn that skilled trade. And I think that that's, there's always that kind of worry when people think, they hear like robots and they think, it's something that's going to take away a job.
Right.
But it's not. This type of robotics is not that. What it is something that a welder can work with, and it can make them more productive, which can then, hopefully, help to plug gaps that already exist in the labor market in British Columbia.
Now, how far ahead of the curve is BCIT with this? Because the first time I heard of a cobot was last week when you guys talked about it. So I would assume you're one of the first.
I think, like, cobots have been around for a few years. I think that they really started getting marketed as like welding tools maybe a year and a half to 2 years ago. We've had this cobot for about a year. I got it from Lincoln as there was their first one. They'd used it as a demo unit across the country, and then they sold it to us. So we're, in terms of I think we're pretty, it's pretty new still. There are definitely some shops in British Columbia that have them, but it's not, it's definitely, it's a really excellent opportunity that we have. I'm thankful for C-SPAN for having provided the money for our center for us to be able to purchase this. And I think, I think in terms of the education, I think we're pushing that boundary.
Speaking of pushing boundaries, what do you think is the future of these things? I mean, presumably they're going to get faster, more sensitive, etc.
Yeah, I think where the future will come is, so the cobot is still quite dumb in many ways. It's a robot, right? And so there's lots of things where with welding things can go wrong if the pieces don't fit together exactly right, or you start to get distortion from welding, or these types of things. The robot can't really like deal with those very well. The future, I think, is integrating the cobots with cameras and having machine vision that can start to look at the weld itself while the weld is being performed, and start to so that the robot can react to things that it's in quotation seeing, right? So if it sees things starting to distort or the path's not exactly what it's expecting, right now it's very, it can't really deal with anything like that. If it's not ideal, it just, it won't do the weld properly. So I think that's what we'll see, is that you'll start to see, and there is a local company called Novak that's done a lot of good work kind of pushing into that space. That you'll start to see those integrations with the cobots, and they'll start to get a little bit smarter. They'll be able to deal with like kind of common fit up issues and other types of things like that, and which will make them easier and easier to program.
Okay, and if people are interested in this, and I would think they would be, say some company was looking into getting cobots or other educators, where would they go to find out more?
I think, there's lots of companies that sell these things, and there's lots of companies that integrate them. I think, but if someone wanted to come to BCIT and they wanted to see what we have, and they're local in British Columbia, they'd be more than welcome to come down, and I can show them the cobot that we have, and I can show them, what it can do. And we're always open to have industry or anyone who's interested want to come and take a look at these things. So that would be a good place to start.
Okay, great. Thanks for joining us today, Mathew.
Yeah, my pleasure. Thank you for having me.
Thanks for listening to the Construction Record Podcast. You can hear us on Apple Music, Amazon, and Spotify, as well as at theconstructionrecord.libsyn.com and on the Daily Commercial News and Journal of Commerce websites. Thanks again for listening.